Greeting everyone. My name is Panjavithu and my fellow here is Thamonwan Supanit and Thanapat Atipunyawong. Today we will present you on our design of the artificial lower esophageal sphincter or artificial LES. So I would like to give you an overview of our presentation. So our presentation will be cover introduction, literature review, methodology, conclusion, and references, respectively. So let's start with the introduction. So what is gastroesophageal reflux disease or GERD? From now on, we will call GERD. GERD is a widespread chronic upper gastrointestinal condition, affect a significant portion of the population in Thailand. So from the research, we found that there are 7.4% of Thai population or 5.3 million of Thai population experiencing GERD symptom. GERD symptom including chest pain, or sometimes patient can trace a sour taste in their mouth. When we cure it, we require some laparoscopic surgery. So hemorrhage from open or laparoscopic surgery is a first problem. Second problem is the acid reflux from the stomach content, which will reflux into the esophagus. First one is the limitation of conventional method. There are three: one, artificial sphincter, and surgery procedure, proton pump inhibitor, or medication. Lead to our objective of the project. First one, we would like to propose the alternate solution to elevate GERD. Second one, we would like to design a new novelty device to elevate GERD as a bridge to recovery. And third objective is to monitoring the peristalsis movement of the esophagus.
So moving on to the literature review, first we need to understand the anatomy of the lower esophageal sphincter or LES. So these sphincters are located in between the chest and abdominal cavity, meaning that it's right in the same place as diaphragm. So this sphincter consists of two types of smooth muscle fiber along with the health muscle from the diaphragm as well as the branch of the ligaments. So the main feature of this sphincter is to contract itself, preventing acid reflux from the stomach up to the esophagus. However, when it has not been triggered by the peristalsis or stimulus from the neuron control, it commonly occurs due to the excessive acid that exceeds the level within the stomach or even the gas from fermented food within the stomach, causing the sphincter to undergo the process of the transient lower esophageal sphincter relaxation or TLESR. So this type of relaxation are one of the invisible symptoms for people who suffering with GERD. To diagnosis this GERD, we need to it can be done by two ways. The first one is the visualization can be done by using the barium and undergoing the fluoroscopy process. Or additionally, for a more safer procedure, the physician can suggest the usage of endoscopic to observe the real-time environment within the upper GI tract. Another ways of diagnosis is to use the manometry to measure the pressure with the catheter that inserts along in the esophagus and as well as the lower esophageal sphincter. Also, the usage of pH monitoring to measure the overall pH within the esophagus can be a great tool to assess the current situation. So currently in the conventional treatment, the physician commonly gave the patient the proton prohibit inhibitor. So these inhibitors are used to prevent the excessive acid production that are used to digest the food within the stomach. However, due to the complication of this drug, it can cause the bone regeneration process to slow down or even the insufficient of the vitamin if being consumed exceeds the recommended level. So the alternative solution that we had done some research on. So one of which is the LINX reflux system. So this is the bracelet composed of magnetic buds that are surrounding the external LES. So when the food is passing through, it will trying to push down the LES and going into the stomach, and these bracelets are using the magnetic field to contract itself, keeping the sphincter closed all the time. However, there's some complication due to the usage of the magnetic field that cause the patient to unable to undergo the MRI process or even the tangle ligament after prolonged deployment. And another procedure is the STETA procedure. So this one we use the catheter to perform the electrotherapy to stimulate the muscle, making it regenerate. Again, allowing the muscle to reform its functionality. However, this procedure needs to be done multiple times and it's suitable for patients with certain condition only.
Moving on to meteorology, we improve LES function while minimizing invasiveness by designing a balloon collector system with piezoelectric sensor for precise pressure measurement and real-time monitoring. And erratic balloon allow for LES expansion and contraction. We use biocompatible polyurethane and Miley coated copper for safety and durability. The system includes a microcontroller for data acquisition and antenna for wireless power and data transmission. Before deployment, we assess area pressure with esophageal manometry to customize the microcontroller for each patient. During deployment, the device is attached to the esophageal wall and the balloon is infested to adjust the LES lines. After deployment, we continually monitor LES pressure and movement, comparing data with pre-deployment assessment to measure uh, improvement and ensure the system effectiveness. Let's move on to the component of our artificial lower esophageal sphincter prototypes. There are concept of T-part. The first one is polyurethane shell, providing high elasticity and durability, offering resilient under constant load. It also protect the internal compartment, ensuring safety and efficiency. And the second is piezoelectric transducer, directly contact to the LS wall, detecting LS muscle movement or peristalsis. This convert mechanical power into the electrical energy, providing real-time data on the state and strain experienced by LS. And the third one is portable rigid plate embedded with the circuit and transmission unit offer mileage insulation and a rigid structure that helps prevent over elongation and potential material failure. Artificial LS operates by detect the chain of muscle movement or the peristaltic movement. When the LES muscle contact, the balloon retains its shape, blocking fluid from passing through. And when the LES muscle relax, the balloon expands to create the wide passage for food to move from the esophagus into the stomach. Circus system operation. After initialization, the microcontroller and the communication protocol are activated. The system continually monitor pressure data from the piezoelectric material on the balloon and amplifies the signal using the analog front-end unit. The signal are converted from analog to digital using ADC and transmitted wirelessly to the external processor via I2C protocol. The processor converts the data to the pressure units and plot the pressure over time for the analysis. Based on the pressure data, the feedback are the feedback and control signal adjust balloon inflation. The system is powered wirelessly from the external power source for the stable supply. The diagnostics run to check from the error or safety concern, ensuring the continuous operation. The conclusion of our artificial LS evaluates advanced material and engineering for optimal performance and the patient comfort. This multidisciplinary approach balance flexibility, durability, and biocompatibility while providing effective release. With ongoing research and testing, we aim to make this technology is a valuable treatment option for LES disorder. And here is our reference. Thank you for attention and listening.